Hi guys, welcome to another one of RG Dollar lectures, and today I'll be focusing on Einstein's equation, and this falls under physics of the atom. So the equation that Einstein proposed is that E is equal to delta mc squared. Basically, when you have an unstable nucleus which undergoes radioactive decay, the nucleus will disintegrate into new daughter nuclides. You will also have the emissions of alpha, beta, or gamma, as well as you can have some neutrons, and you have energy. Einstein was using this equation to explain the origin of that energy. Where did that energy come from? And he was able to establish that this energy comes from a difference in mass. So when you have that nuclei disintegrating in its ability to achieve stability, right, in its process to achieve stability, you will have the mass of the reactants becoming less. So if you compare the total mass of the reactants to the total mass of the products, you are going to see a smaller value. So when you see that, you will then understand that that difference in mass is what is transformed and emitted as energy. All right, so your mass is given in terms of U. So it's 1.6 by 10 to the minus 27 kilograms. And we have said that the difference in mass is what is emitted as energy. Now, I was looking at an example in order to show how you utilize the equation. Now, delta M is your mass effect, which can be measured in terms of U, which is unified atomic mass, or kilograms. Now, because the mass of an atom is so tiny, you will find that the value of U can be very small, right? So U can be converted to kilograms by multiplying by 1.66 by 10 to the minus 27. So here in this example, I'm going to basically show you how to apply the formula. So if we have bismuth, it breaks up into thallium plus a helium atom. Right? So what you will find is that you have the mass of bismuth given, and it is the only element on the left hand side of the equation. So it is the only reactant. So the products will be this one here plus the alpha particle. So what I did is, you will normally be given a table of values with the mass. So we are going to find the mass of this element and alpha particles. All right, so let's move on. So then you have the total mass of the bismuth is compared to the other two masses of the products. You will get a value in terms of U. Now this value, I know it's really long numbers, but try not to approximate because the change in mass is sometimes very, very small. If you approximate, what you will find is that you will not get an accurate answer. So utilizing all of the values, I would have gotten 0.006656 U, and then I would use the equation E is delta mc squared, and I would work out what my energy is. I would convert my delta M into kilograms by multiplying by 1.66 by 10 to the minus 27, and then I would multiply by the speed of light squared. So my total energy becomes 9.94 by 10 to the minus 13.